Hello students, welcome to my channel Elite Maths class. Today I am here again with another part of matrices. Matrix is a very important chapter of class 12. In respect of your exam point, it is very important. Matrix and determinant, it is a part of your algebra. There will be approximately 2-3 questions from matrix and from determinants. So this is very important topic, important chapter, as well as for entrance exam also 1 or 2 questions are definitely there from matrix and determinants or related to matrix or determinants. In my previous 2 videos I have already discussed some definitions and properties and operations. Now let us see some more things of matrices. Here I am starting with scalar multiplication. Scalar multiplication is an operation on matrices. Scalar multiplication means when we multiply a matrix by any scalar, then what is the result? This is scalar multiplication. See, here I have taken a matrix of order 3 by 3. For scalar multiplication, you can take any matrix, or that is of a matrix of any order. That is, scalar multiplication can be done to any matrix, whatever the order of the matrix is, it does not matter. The first thing, we have to take a matrix, say it is taken as 3 by 3 matrix, a matrix of order 3 by 3. Now let us take a scalar quantity k. Now what will happen if we multiply the matrix A by this scalar A? Simply the matrix is written in representation form, then this matrix will be multiplied by this scalar. Now what to do with this scalar? Here you just remember that when this k is multiplied to this matrix, then this scalar will be multiplied to each and every matrix of the each and every element of this matrix, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. This is the matrix. Then what to do with this scalar? This k scalar will be multiplied to all the elements of the matrix. Clear? This is the thing. When the matrix, any order is multiplied by a scalar, any order, it is similarly applicable to any order, say a matrix of order k into x, y, z, u, v, w. This is a matrix of order 2 by 3. Then what will be the resultant matrix? You just multiply the scalar to each and every element. It is kx, it is kx, ky, kz, ku, kv, kw, etc. So this is scalar multiplication of a matrix by a scalar. Now think the reverse case, that is, if this is the case, then what to do with the scalar multiplication? That is, in simple algebra or arithmetic, we take out some common factor. For example, say x square minus 7x, there we can take out common x, then what will remain? X minus 7. Same thing here we can, this is also a scalar multiplication property. Here say it is the given matrix, this one is the given matrix in this form. Here we can find that every element is k times of the element, this one is k times of A1, k times of B1, that is every element has a common factor k. Every element has a common factor k, then this will be the result. That is, from this matrix we can take out k as a common factor. Here also the same thing. This is the scalar multiplication of a matrix. Now see some properties of scalar multiplication. What properties? The first thing is, here another thing, say in general form A equal to, let A is a m by n, k is any scalar, then what will be ka? This will be k a I j m by n. Order of the matrix will be unchanged and this scalar will be multiplied to every element of the matrix. Then some properties of the matrices, say sum of two matrices. First one, these are the properties of scalar multiplication. Say K is multiplied to sum of two matrices. Here these two matrices are given, say it is of any order. Then what to do with this K? This will be equal to Ka plus Kb. Second thing, for a single matrix, say two scalars are there, K1, K2, two scalars, and single matrix A is there. Then what will be the resultant? It will be K1 into A plus K2 into A. Another property is, say K1, K2 into A. This is equal to K1, K2 into A. This one are same thing. So these are three very simple properties of scalar multiplication. Now let us see the another very important property or definition or operation on a matrix. This one is called transpose of matrix. This is an operation which is applied on a matrix. That is, for example, the addition of two matrices is applied in two matrices. In a single matrix you can't find the addition. That is, to apply the addition, these are called binary, and transpose is an unary operation. That means in a single matrix we can apply the operation. Now what is transpose of a matrix? This part, transpose, is very important. After defining transpose, another two types of matrices are also defined based on transpose. So the next part is transpose of a matrix. What is transpose of a matrix? Let A is a matrix of order m by n. What is transpose of a matrix? Transpose of a matrix means we just have to write every element in a row in the given matrix. That row will be the column in the another matrix. That is, we have to interchange all the rows into columns. Automatically all rows of the given matrix will be the columns and all columns will be rows. That is the simple thing, we have to interchange the rows and columns. And transpose of a matrix, let A equal to this be the given matrix, then transpose of A is denoted by A transpose or A prime or A small t. These are some notations. You may use any one of these, a t, A prime or a small t, to denote the transpose. Then what will be A transpose? A transpose will be A ji of order n by m. Now see the thing, what is there in the transpose of a matrix? The order of the matrix, given matrix is m by n is this is the order of the transposed matrix. That is, here the number of rows is m, here the number of rows is n, interchanged. Number of columns is n, here the number of columns is m. Here every element is represented by aij, it is ji. That is, here if the element is a 2 1, this lies in second row first column element. In the transposed matrix, this element will go into the first row and second column position. That is, every element of row in a row will go into the column. For example, let us take A equal to 2 3 5 4 1 0. This is the given matrix. So what will be A transpose? A transpose will be, see, this is the first row, this one will be the first column, 2 3 5. The second row, 4 1 0, this will be the second column. Now see, here the order of the matrix is 2 row 3 column, that is 2 by 3. Here see, there are 3 rows and 2 columns, so it is 3 by 2. Now see, this one, the position of the element is 1 1, it is at the same position 1 1. For example, ij ji, if I equal to j, then it is same. But here the position of this element is 1 2, that is first row second column. Here this element goes here. What is this position? This is second row, first column, 2 1. Now see, it is 1 2 position, at 1 2th position, it is at 2 1th position. That is, every element will interchanges its position accordingly. All rows changes to columns. So the simple thing is row and columns are interchanged, then you will get the transposed matrix. So this is the transpose of a matrix. To find transpose of a matrix, what we have to do, just write the rows into columns, then order will be changed and transpose is obtained. Clear? Now see some properties of transpose of a matrix. These properties are very important. Properties of transpose of a matrix. The first property is properties. For a given matrix, a transpose represents the transposed of the matrix. Then if you take again transpose, that is, a matrix is given, take the transpose, then again transpose of the transposed matrix, you will get the original matrix. Number 2, for two matrices, if they are computable for addition or multiplication, their transpose is equal to A transpose plus minus B transpose. The third property is A transpose. Here another thing, the multiplication of two matrices I have not defined yet. In my next videos I will define how to find the product or multiplication of two matrices. Here just remember the properties. Say A and B two matrices be such that you can find the product. Then what will be the transpose of the product matrices? This will be B transpose into A transpose. Simple relation. Just remember that when product of two matrices, transpose of two product matrices is taken, then this is exactly equal to, in reverse order, take their transpose and find the product. Fourth one, it is also A inverse is not defined yet. This is multiplicative inverse, then take the transpose. It is exactly equivalent to first take the transpose, then take the inverse. Fifth property, another one, adjoint of a matrix is not defined yet. I will define in my next video. What is adjoint? I will define later on. Now just see the property. For a square matrix you can find the adjoint. Then after taking adjoint, take the transpose. It is equivalent to first take the transpose, then find the adjoint. These are equivalent. For the last three properties, product, inverse and adjoint, I will define later. Now just remember the properties. Now as we know the transpose of a matrix, now we can define some new matrices. These two matrices are very useful. The first one is symmetric matrix. Symmetric matrix. For symmetric matrix, a matrix must be a square matrix. Let A be a square matrix such that A be a square matrix such that A transpose equal to A. A transpose equal to A. That means whenever a square matrix is given, you take the transpose, and after taking the transpose, if we see that the transposed matrix is same as the original matrix, then this matrix is called a symmetric matrix. For example, you see this one, let A equal to say A, B, C, H, C, F, H, G, F. This is a particular and important one. This is the given matrix. Now let us take the transpose. So what will be A transpose? This one is the first row. Now we write this row according to column A, H, Z. This one is the second row. You write this according to second column H, B, F. Third row, write in third column. Now see these two matrices A, H, G, H, B, F, G, F, C. That is, these two matrices are same. A transpose equal to A implies A is a symmetric matrix. So this one is the condition, a transpose equal to A. If transpose of a matrix is equal to the given matrix, then the matrix is called a symmetric matrix. The next one is skew-symmetric matrix. Almost similar, the condition is similar to a symmetric matrix. This is skew-symmetric matrix. Symmetric matrix. For this also the matrix must be a square matrix. Let A be a square matrix such that if you find the transpose, this is equal to the negative of the given matrix. If this happens, then this matrix is called a skew-symmetric matrix. For example, let A equal to 0 3 minus 4 minus 3 0 2 4 minus 2 0. Scalar multiplication already defined. Now let us see what is the transpose of this matrix. Now what will be the A transpose? A transpose will be, see, this one is the first row, 0 3 minus 4. So we are writing 0 3 minus 4. This first row is written first column. The second row minus 3 0 2 minus 3 0 2. Second row is written along second column. Third row 4 minus 2 0 4 minus 2 0. Third row is written as the third column. So this one is the transpose of this matrix of the given matrix. Now now let us check, is this equal to minus A? See, this is 0, same. Here it is 3, but here it is minus 3, minus 4 4, 3 minus 3 3, 2, here it is minus 2 4 minus 4 minus 2 2. That is, every element is of opposite sign that of A. In scalar property that was discussed in my previous video, scalar property, we can multiply each and every element by a scalar. Now let us take here as minus 1 into minus 1, 0 minus 3 4, 3 0 minus 2 minus 4 2 0. Here we can write this minus 1 into minus 1 plus 1, so the value is remaining same. Now what we have to do, let this minus 1 at the outside, this minus 1 as a scalar you multiply to the matrix. So what will happen, if you multiply a matrix by a scalar, then this scalar quantity will be multiplied to each and every element. That is, this minus 1 will be multiplied to each and every element. So what we are getting, 0 minus 1 into minus 3 3, it will be minus 4, it will be minus 3 0 2 4 minus 2 0. Now check these two matrices, are same. So what we can write, minus of A. So finally we got A transpose equal to minus of A, implies A is a skew-symmetric matrix. So if these two things are clear, what is transpose of a matrix and the properties of a transpose, what is symmetric matrix, what is skew-symmetric matrix. Related to symmetric and skew-symmetric matrix, a very important theorem is there. Sometimes some questions are asked based on this theorem. The theorem is every square matrix can be expressed as a sum of a symmetric matrix and a skew-symmetric matrix, uniquely is. Every square matrix, you just write here A. Every square matrix A can be expressed as the sum of a symmetric matrix and a skew symmetric matrix uniquely. This expression will be unique, as say this is the given matrix A. A can be written as A plus A half of A plus A transpose plus half of A minus A transpose. This is the expression, and this expression is unique. How every square matrix, this matrix must be a square matrix. Every matrix can be expressed as a sum of two matrices, of which one is a symmetric matrix. Here this matrix will be symmetric and this matrix will be skew symmetric. So this is the theorem. It is, proof is very easy, you can try at your home. What is the statement of this theorem? Every square matrix, it is for any square matrix, either it is of 2 by 2 or of 3 by 3 or 4 by 4, every square matrix can be expressed as a sum of two matrices. This one matrix, this one matrix. Here this matrix will be a symmetric matrix and this matrix will be a skew symmetric matrix. Simple algebraically or arithmetically, you just see the calculation. Half of A plus half of A means A, plus half of AT minus half of AT cancel. So this expression is true. Now this structure always represents a this structure always A plus AT always represent a symmetric matrix, and this structure A minus AT always represent a skew symmetric matrix. So this is true. I am not going for the proof here. So in this video I have defined scalar multiplication, then transpose, symmetric matrix, skew symmetric matrix, and this theorem. So all these things are clear. In my next video I will define another operation on two matrices, that is which one is also very important, matrix multiplication. Hope this video is very helpful. You have understood everything defined in this video. If you are very new to my channel, please subscribe my channel and don't forget to press the bell icon to get notification of my further videos. Thank you very much.